MLinkPlanner is software for point-to-point and point-to-multipoint link planning. In this video, I will demonstrate the main features of MLinkPlanner. For more details, please refer to the user manual on our website at wireless-planning.com. When you start MLinkPlanner, a new project is automatically created. The installation file comes preloaded with several test projects which you can use to start working in MLinkPlanner. As in the main user menu, the program uses a multi-level tree interface. When you select one of the menu items, a panel corresponding to the given item will open next to it. MLinkPlanner also has a context menu on the base map. You can use them to quickly perform various actions. The options for this context menu directly depends on the selected main menu items. You can select one of the preset base maps or configure a custom base map by specifying a tile server URL. Map navigation is performed with a mouse. Use the mouse wheel to zoom in or out of the map. When the map zooms into level 12 or higher, the application begins to download SRTM elevation data and tree cover data. The status bar displays the pointer's geographic coordinates and the information about the elevation above sea level and the height of the tree canopy. Before creating microwave point-to-point links, point-to-multipoint base stations, or subscriber station links, you must first create some sites. Sites are locations that can be connected via point-to-point or point-to-multipoint links. A site has only three characteristics, which are name, latitude, and longitude. To create a site, go to the Sites menu and enter the site name and coordinates in any format. To make this easier, you can right-click on a location within the base map and use the Context menu to create a new site. You can also rename the site later and can also move the site if you have it already created. Please note that the context menu with the line Create New Site appears on the base map only when you are in the Sites main menu. You can also import sites into MLinkPlanner from any spreadsheet through a CSV file or just copying it directly from the workbook itself via the clipboard. After creating some sites, you can create point-to-point links and point-to-multipoint networks. To create a point-to-point link, go to the Point-to-Point menu. As a first step, we must include the spec file for the equipment family that is supposed to be involved in the project. Click on the Add a New Product Family button in the Point-to-Point menu to add the product family to your project. To download the product family files from our website, click on the Download Product Family Files button, and a link will open up in your browser. We are continually updating the files with equipment parameters, but if your desired equipment is not on our website, then first create the equipment spec file. We'll mention how to do this later. Here you need to specify your approach to determining the reliability of the microwave link, and also, if necessary, enter any additional parameters to calculate the performance and availability objectives. To create point-to-point links, click on the Add button at the top of the Point-to-Point menu, and a program will prompt you to select the link ends. In this case, Site A and Site B from the sites created before. The link will now appear in the point-to-point tree, and the panel will open with its parameters. Please note that site locations can be changed here in the base map. Once the link is created, you can generate its path profile. Simply do this by clicking on the Generate Path Profile button in the toolbar. You should specify the average building floor height. This is typically 3 meters or 9.8 feet in this window. The OSM project database usually contains information about the number of floors of the buildings rather than their height in meters. Building heights in the path profile will usually be based on the number of floors and the floor height. You will also have to specify the height of the buildings that the OSM project database does not have information for. These will be highlighted in red on the path profile. Once the user clicks OK, several seconds later the information about terrain elevation and clutter characteristics along the path profile will appear in the table cells. The path profile view will be displayed at the top right of the panel. If you highlight a segment along the path profile by clicking and dragging the left mouse button, the segment will also be highlighted in the terrain elevation table, the clutter table, and on the base map. If you select rows in the elevation or clutter table, it will highlight the corresponding section in the path profile view and on the base map. Terrain elevations and clutter can be edited manually in the corresponding table cells. To edit multiple cells, select the required cells and enter a new value. To delete the entire row in the table, click on the triangle icon at the beginning of the row to select either a single row or multiple rows. You can do this by dragging the mouse or holding the Shift key and using the up or down arrow keys followed by the delete key. MLinkPlanner also allows you to create path profiles manually, entering all the elevations and obstacles along the path. After creating a path profile in the drop-down list, select the product family from those previously added to the project, then selecting the equipment product model, channel bandwidth, and frequency band. After this, general information about the selected equipment, its image, channel bit rates, transmit power, and receive parameters for each supported modulation types will appear below. To view link performance calculations, click Report. You can switch between the short and the full report view. The short report view displays only calculation results. The full report view displays input parameters, calculation results, the path profile drawing, and the path profile diagram on the base map itself. You can print the report or save it as PDF, Microsoft Word, or Excel. In the propagation model menu, the user can select the various propagation models, which will be used to calculate the microwave link performance as well as some parameters of these models. MLinkPlanner can calculate the minimum main and diversity antenna heights using different clearance criteria. To calculate the minimum antenna height, click on the corresponding icon. In the window that opens, specify the optimization parameters. Once the required preferences are selected, click Optimize, and the minimum antenna height will appear on the left. The height of the response antenna is fixed at the current value. The path profile will display the criteria used to calculate the antenna height. Click Apply to change the antenna height according to the calculated value. To discard the calculated value, simply click Cancel. Reflection analysis allows the user to identify possible specular reflection points on the path profile and evaluate the application of various specular reflection reduction methods. Diffraction analysis allows the user to estimate diffraction losses due to obstacles on the path profile. Diffraction losses may be due to the inability to meet the clearance criteria. In MLinkPlanner 2.0, you can choose one of the following diffraction methods. Recommendation ITUR P526-15, aka the complete Bullington method. Degut principle method with correction. This is known as the ITUR P526-11, or the Epstein-Peterson method. Planning a point-to-multipoint network in MLinkPlanner, you have the ability to create different coverage study types for point-to-multipoint base stations, create availability calculations for base station to subscriber station links. To create a point-to-multipoint network, go to the point-to-multipoint menu. As a first step, we must include the spec file of the equipment family that is supposed to be involved in the project. Click on the Add a New Product Family button in the Point-to-Multipoint menu and add the product family to your project. To download the product family files from our website, click on the Download Product Family Files button and a link will open in the browser. We are continually updating the files with equipment parameters, but if your desired equipment is not on our website, then first create the equipment spec file. We'll mention how to do this later. To create a base station, click on the Add button at the top of the Point-to-Multipoint menu. Then select a site from the list that appears. The base station will now appear on the map, as well as the width of the angular sector and its direction. When creating a base station, one base station sector is always automatically created. You can add as many sectors to the base station as you need. Simply click the corresponding button. In the drop-down list, select the product family from those previously added to the project. Then select the equipment product model, channel bandwidth, and frequency band. After performing this task, general information about the selected equipment, its image, channel bit rates, transmit power, and receive parameters for each supported modulation type will appear below. For each base station, you can set subscriber stations. To create a subscriber station, click on the Add Subscriber Station button within the sector to which it will be linked. Select the site from the list and the subscriber station panel will now open. In the drop-down list, select the equipment product model. The equipment family for the subscriber station is the same as the family specified for the base station sector. Below you will see general information about the selected equipment, its image, channel bit rates, transmit power, and receive parameters for each modulation type. The antenna pattern for a subscriber station is not specified since it is always strictly in the direction of the base station to which it is linked. The frequency is also the same as the base station sector frequency. Conveniently, you have the ability to create subscriber stations by using the context menu on the base map. In order to do this, within the main menu, select the base station sector to which the new subscriber station will be linked. You can also select the base station sector directly on the map by double-clicking on the degree designation of the desired base station sector. Right-click on the site for the subscriber station and select Create Subscriber Station in the context menu. If you right-click on a subscriber station that has already been created, an additional line will appear in the context menu, which will state delete all subscriber stations associated with the specified site. With this, you can delete a subscriber station, but please notice that you delete only the subscriber station, not the site that it is connected to. An availability calculation can be performed for each of the base station to subscriber station links. This availability calculation contains a detailed analysis of all clutter along the path profile. This calculation enables you to choose the parameters of the antennas and equipment for each link. In the subscriber station panel, use the Generate Path Profile button to create a path profile between the base and subscriber stations. Use the Report button to create a link report. You can select the required report type, short report or full report. There is also a report titled Base Station Performance Summary in the Base Station Sector menu. This allows you to see the maximum achievable speeds for each subscriber station. The analysis features are generally the same for point-to-multipoint as they are with the point-to-point links. These include antenna minimum height calculations, reflection analysis, and diffraction analysis. The coverage study calculates the estimated coverage of the base stations. The study approximately determines the area where the subscriber stations can be located and gives a rough estimate of the available link capacity to this location. To determine the exact height and type of the subscriber station antenna for the required link capacity, you must perform a detailed link availability calculation. A coverage study is performed under the following conditions. The parameters entered for each of the base station sectors are used for the coverage calculation. A typical subscriber station installation is used in the calculation for predicting coverage in the entire study area. The typical subscriber station parameters are entered into the coverage study details menu. The calculations do not take into account the excess path loss due to clutter loss, which include buildings and trees. Before starting a coverage area study, you must first specify the parameters of the base station sectors that will be involved in the study and set those base station sectors to active. Refer to the base station section for information on setting these base station parameters. Please note that the coverage study for the base station sectors will only be carried out if the checkbox located to the left of the base station sector name is active. To configure the coverage study options, go to the Coverage Study Details menu. You can perform 3 coverage study types for point-to-multipoint systems. Received power studies at subscriber stations. In this case, the map shows the areas where a given signal power level is present at the subscriber station receiver. Best server. In this case, the map shows the identity of the transmitter supplying the strongest received signal at each point. Carrier-to-carrier interference plus noise ratio at subscriber stations. To perform these calculations, click Calculate Coverage. You can then save the result of the coverage calculation as an interactive web page, as a bitmap, or as a KMZ file. You can also perform a visual comparison of the two different coverage result calculations, evaluating their effect on coverage of a particular change in various parameters of the base and subscriber stations of the point-to-multipoint network. To add the performed calculation to the comparison, click the Add Coverage to Compare button on the top toolbar. When you go into the Compare Coverage menu of the main toolbar, this calculation result will be located on the left side of the screen. On the right side of the screen, the result of the current coverage calculation will be displayed. For example, you can change the height of the sector or sectors of active base stations, and after performing the coverage calculation, you can see how these changes have reflected in the result compared to the previous calculation. In the Map Layers menu, the user can control the layers that are displayed on the map and enable and disable the display of layers and change their style. The base map is always below the other layers. The next one in sequence is the coverage layer. The order of the layers can also be changed. By default, the following layers are always present: sites, point-to-point links, point-to-multipoint base stations, subscriber stations. The user can change their order and toggle them on and off. The user can also change the style of the layers, but it's not possible to delete them. The user can also load and display any point or linear vector object in KML format as a layer on the map. This may be, for example, power lines, pipelines, and other infrastructure objects. MLinkPlanner 2.0 uses special format equipment files with an EQT file name extension. These files contain specifications of different types of point-to-point and point-to-multipoint equipment. The software comes with a set of such files for a wide range of modern point-to-point and point-to-multipoint equipment. This is helpful as the user does not need to search for detailed specifications for the main radio equipment, as they're already built in, and one such file may contain specifications for a whole family of products. The common parameters for this family are modulation and coding parameters, as well as a set of bandwidths. An example for point-to-multipoint equipment is the popular AirMax family by Ubiquiti Networks, which includes many products of base stations and subscriber stations that are compatible with one another. Equipment for point-to-point example family is FibeAir IP20N by Ceragon, which includes a set of external placement of different radio frequency units known as RFUs, or even different frequency bands. If the file with the necessary equipment was not included in the supplied set, MLinkPlanner 2.0 provides a tool, Equipment Editor, with which the user can prepare the specification file. To start the Equipment Editor, click on its icon at the top toolbar. Fill in the family field and the family information field, although please note that this is just an information field. Navigate to the Family Parameters panel and fill in all the products in the family, including all the frequency bands which are available, the modulation, and the coding. After completing this information, click OK, and this panel will now close. The entered information will appear in the products, frequency bands, as well as the modulation and coding table of the main panel of the Equipment Editor. Choose the type of equipment family, whether it's point-to-multipoint or point-to-point. For the point-to-point family, fill in the information about the maximum available branching configuration, available branching types, available diversity options, and the type of adaptive equalizer parameters. All this information will be taken into account in the future when configuring point-to-point microwave links based on this product lineup. Now you can enter information about each product. Select your product from the drop-down list. Fill in the product information field, but please note that this is just a text field. Select if an external antenna is used with this type of equipment or if an antenna is built into the equipment itself. It is often the case for point-to-multipoint base and subscriber stations to have an integrated antenna. As a result, select the integrated antenna enter its gain, and download the antenna pattern file in the MSI file name extension format. Insert a photo or graphic image of the product. You can download the image from a file or through the clipboard using the tools above the image. If one picture is used for all products, then indicate this using the checkbox in the upper right corner, as this will significantly reduce the size of the file with the spec. From the bandwidth drop-down list, select the required product bandwidth. Fill in the columns channel bitrate, transmit power, receive threshold for each modulation type. For point-to-point equipment, it might be necessary to additionally fill in the adaptive equalizer parameters for each modulation type. And if the family equipment supports co-channel mode, then cross-polarization canceller effect, otherwise known as XPIF, and carrier to interference ratio, CO/I parameters as well. Repeat this for all bandwidths supported by the product. After filling in the information for each product, save the specification file. Please note that it will be saved in the EQT file format type. For your convenience and to save you some time when filling out specifications, several tools are provided. Copying and pasting groups of cells from spreadsheets is also supported. In this menu, you can change parameters for the project. You can change things like user interface, base maps, the coordinate system, and the distance and height units of measure. For more details, refer to the MLinkPlanner user manual or on our website wireless-planning.com.